All right, everybody, welcome to this week's edition of Firepunk Friday. We're here for episode 2 of this, and today Levon and I are going to tackle the subject of nitrous. So we've had a lot of people asking about that, and we're going to tackle everything from nitrous on your street truck to nitrous in our Pro Mod and kind of what we've learned over the years. What we know isn't gospel, but we have learned a lot of things over the years. So before we dive into that topic, we're going to talk a little bit about what's going on around the shop this week. We're getting into race season, and that translates to crazy season at the shop.
Right. Yeah, it's something that this is the time of year that normally it's warm and sunny outside and everybody's got an itch to go racing, and it just got done snowing all morning. So it's very bipolar weather here in Ohio recently. But like last week, I was at the track Thursday night, and that was, had a buddy who had a Tesla Plaid who wanted to get one back on me because I beat him in his Lamborghini Huracan, and then he sold that and bought a Plaid because he wanted to go faster. I guess he didn't like getting beat by a diesel truck. But no, that he was all in good fun, and went up there and raced him, and that really gets you in the fever to go racing.
Yep. Yeah, so we're coming right up on the ODSS season opener, and so we're right in the process of getting the S10 ready again. We're supposed to be getting the engine back here today, and then we get to stuff that all back in. Should be a pretty straightforward deal. We're not really changing much of anything other than we're having to put everything back from the radial tire setup. So we've got the rear end all apart, changing out the rear gear. We run a 290 rear gear when we're on radials, and then we go back to the 325 gear with the big tires. So that, and changing out the front tires to get ride height right, and changing stator. So a couple little things like that, but nothing too super crazy. So we're hoping by the weekend we can have the truck together and be comfortable for next week. And
it always seems like it's just going to be an easy process, but there's always, it takes 3 guys about 40 hours to put it back together. So, and we try to pretty much do that evenings and weekends because try not to get racing too much in the way of our workload.
Mm-hmm. And then last week we were able to do first fire on Byron Klein's Enforcer. I don't know what you'd call it.
It's a Fummins.
Yeah, so, it's a Fummins, and should be a pretty nasty little truck. I think you'll mostly see it racing East Coast and maybe some Rudy's event stuff, but he wants to go as fast as he can. I think maybe run singles elite at Truck Wars, and I don't know, maybe see him at some 590 races and some other outlaw stuff. So that's a fun little project we've been working on. And then we're also really getting serious about getting Justin Ziegler's truck finished up, and need to get that thing on the track for testing for UCC.
Right. Yeah, Ziegler's truck is like it's in the 90% finished category, and it's always that last 10% that takes 90% of the time, and it can just nickel and dime you on these projects because you look at it, and you're like, wow, this thing's almost ready. But then you're like, yeah, we still got to pull the motor back out, spray paint the whole front end that we just fabricated, and then do final assembly on everything, finish all the plumbing for the fuel and the oil feeds and drains, and rebend some high-pressure fuel lines because there was just a bunch of small changes that went into it, and that stuff can really eat up some time.
Yeah, we've got about 10% of the project left. That's going to take 75% of the time. But anyhow, so that kind of covers what we got going on at the race shop. Before we get too much further, I might mention too, since we did our April Fool's video and we did the root beer taste test, a lot of people took that quite seriously, and it was just a fun little gig we did around here. But had quite a few people send in root beer, and that's been enjoyable. Had somebody send us a good bit of Freddy's root beer. I really enjoyed that one. We had a variety pack. I haven't gotten to try all of those, but some pretty unique ones. This one caught my eye, called Dang, That's Good Root Beer. That's pretty creative. And then another one that was pretty cool is this Tommy Knocker root beer. And this one kind of sticks out for the rest of them. I think they're all kind of most of the bottled ones are pretty sweet. And a lot of them have a pretty strong vanilla aftertaste, which this one definitely has a vanilla aftertaste, but also has a pretty strong root beer aftertaste. And then the can was kind of intriguing to me as well. It's got like a zipper wrapper where you can actually pull the wrapper off, and you've got a plain metal can. So found that interesting, but thanks to everyone that sent root beer. We've been enjoying it around
Yep.
here.
If you got other drinks that you think that we would enjoy trying, send them our way, and we'll do a YouTube review on your creative favorite drink of the week. As long as it is non-alcoholic, we can try it during the workday.
Yeah. So I'd say moving on to addressing some questions from the internet. I know one of the questions that was asked on our last video, somebody was asking about transfer cases and AAM axles specifically. Like, what do you need to do if you up the power in your truck?
Right.
And, what have we found with those?
I mean, the factory AAMs they're pretty strong axles. And the quad cab ran the stock stuff. Pretty much 2014 DPC was completely stock axles. 2015, we had replaced the front axle shafts with just new stock ones and had upgraded the drive shafts for bigger U-joints because we were sled pulling it. And generally, if you're just drag racing these trucks, you don't have to do anything to your AAM axles or your transfer case. We went 788 at 181 mile an hour in the Pro Street truck at UCC 2018 with a completely stock transfer case. So I have customers who freak out about popping their transfer case in four-wheel drive at 55 mile an hour, and I'm like, I want 181. It's going to be okay. And I would say sled pulling when you're in low range puts a lot more stress on your axle shafts, and that's where you have to start considering upgrading your axle shafts in the AAM. And so we would generally ream the axle housings on the outside and put a 38 spline Yukon axle in it or a 39 spline Brannick axle in it with a full spool for the sled pull application. But racers, the majority of the racers, putting a good limited slip in the rear is sufficient. I would recommend leaving the differential on the front open unless you're sled pulling, then it's beneficial to go to like an E-locker. But if you put a locker in the front for drag racing, you're going to torque steer terribly unless you have a rack and pinion steering, something to really control it. I know I had to put a True Track limited slip in the front of the quad cab before I had done any steering modification, and on the street, you couldn't erase somebody beside you, you'd have been changing paint.
Right. Well, we had that one truck, I think it was Rick Clark's truck back in the day, where he went from being a sled puller to...
That was Blake Krieger.
Blake Krieger, okay. Yeah. Close.
Yeah, and he had an E-locker.
Yeah, so we tried that at the track, and it resulted in broken front drive shafts faster
front axle
shafts, before we really even knew what happened. So that lockers are an absolute no-no.
In the front.
In the front. Limited slip is a maybe if you have really good steering.
Yeah. On the race trucks, we've gone to limited slip when there's a rack and pinion steering in the front and the truck can go straight, doesn't walk around. And on the drag strip where the surface is flat, it's not bad. But on the road where the road is crowned and you have a limited slip in the front, it will pull you every direction possible, and it's a wild ride. I wouldn't recommend it.
Right. And then transfer cases, like really those are about as bulletproof as you're going to get them. Like,
keep a fresh chain in it and roll with it.
That's about the only thing we've seen is, eventually the chain might wear out, but those transfer cases are really tough, and we've not really seen any need to do anything to them. Let's get into nitrous. Not quite sure where do you want to start.
Well, it's a topic that we've said it in a couple of YouTube comments, and I get it on Facebook quite a bit, and it's like, hey, I'm wanting to buy a nitrous kit. What do I do? And man, it's a loaded question, because with what we've learned in the race trucks, nitrous is a very good power adder when used correctly, and it is a parts destroyer when used incorrectly. Mm-hmm. So when you use nitrous in the wrong application, you can blow turbos up, melt pistons, just cost yourself a ton of money. And when used correctly, you can run it and consistently have consistent results using nitrous every pass and never tear anything up. So that's why we want to try to educate you on the stuff that we found. And you use this information based on your application, because there's too many different variables to really just say, this is how you do nitrous, just do it this way, because you would all have to have the same injectors, same turbos, same everything for it to really be apples to apples comparison.
So let's kind of start with the street trucks. If somebody's wanting to get into nitrous on a street truck, like what's the best approach to take? Like I know ideally we'd like to have a lot of data. What are some of the data points that are of concern and that we would like to pay attention to if we can?
Well, nitrous is pretty much turbo in a bottle. So when you turn nitrous on, you're putting oxygen-rich air into the airstream, which is going to burn more of the fuel that's available. So now your engine is an air pump, and the faster you spin it, the more air it moves through. And you have to be concerned about your turbo, because when you put turbo in a bottle, and you put nitrous in the pipe, all that air is going to make more energy in the engine, and it all has to exit through your turbo. So the biggest failure we see in the street truck guys is they'll have a S472, or let's say an S475, for example, because it seems to be everybody wants a 475, even though they're terrible daily drivers, in my opinion. Again, my opinion, don't be mad. But put an S475 on it, and they make 1,100 horsepower. They make 1,000 horsepower, and they want to add nitrous to it. Well, you're putting this nitrous on the truck. You already don't know what your turbo shaft speed is, because the Borg-Warner turbos don't come with turbo shaft speed sensor, and if it did, you don't have a data logger on your truck to be able to tell what your shaft speed actually is. And then most guys don't even have drive pressure gauges, so they just know they're making 55 pounds of boost. That's all they know. And they put nitrous on it and like whacks another 100 horsepower in it, but they have no idea that they just took their turbo shaft speed from 115,000 RPM to 128,000 RPM. So if a little is good, more is better, right? So take your 80 jet out, put a 110 jet in it, and whack it again. Now your turbo explodes, and you got a fireball. And then you're looking at your turbo manufacturer and going like, wow, that turbo's a piece of junk. I'm going to switch brands. And, I see that happen over and over and over again as people blow up a turbo. And rather than actually educate themselves on why this turbo might have failed, they just blame it on the turbo manufacturer, jump onto another one, and think that that one's going to be better. And it's not necessarily like that. So on a street application, what we want to see is you have to do it within reason for what the turbo is capable of doing, or you have to put an external wastegate on the truck so that you can relieve that extra pressure, or the engine, extra gases that the engine's exhausting, from going through the turbo and overspeeding it.
So would you say if someone, as a way of monitoring that turbo shaft speed, if they would put a drive pressure gauge on it and would keep track of drive pressure versus boost pressure, if they keep that in check, would you say typically turbo shaft speed will stay within check?
Yeah, not always, but as a general rule, the turbo will generally not go past its danger zone of overspeeding unless drive pressure is more than 10 pounds higher than drive. So if you're making 55 pounds of boost and you're making 65 pounds of drive, you're normally safe. If you're making 55 pounds of boost and 90 pounds of drive, you're already in the danger zone. And if you add nitrous, you're most likely going to grenade a turbo. Right. On the S10 with the GT55, those are dual ceramic ball bearing turbos. They're extremely durable compared to the thrust bearing or the journal bearing stuff that's in the S400s. And we'll run boost and drive pretty much 1-to-1 at 115 to 118 pounds of boost and about the same drive pressure. And we'll notice a big difference on drive. When we're at 4,500 RPM, our drive pressure is like 90 PSI, while our boost is still 115. But at 6,000 RPM, our drive pressure is at 118 and our boost is at 115. Mm-hmm. So RPMs make a big difference on how much drive, because the engine's an air pump. The faster you spin it, the more air it's letting out. And that's why most of the turbos that blow up, high RPM burnout, it's just singing a bunch of air through it. Or you're, shifting the thing at high RPM, and that's where you get into danger zone. Yeah.
And the other thing that we often see, like on a street truck, when guys add nitrous, it's typically when they have a nice big fuel system on the truck, and guess what? They're out of turbo.
Right.
So now you're adding nitrous, and you're going to make that power, but now you're also going past the limits of that turbo. So you really need to, like, if you're going to try to go make more power past the limits of what turbo you have, you need that wastegate to be able to relieve that drive pressure. And that's kind of a different can of worms. It takes a little bit of time to learn how to tune a wastegate. And,
a lot of time.
Yeah, well, a lot of time. I mean, we've learned a lot of. We really could probably do an episode on that in itself. Like there's for years we, didn't want to use a wastegate because they are a headache to learn how to use them and plumb everything properly. But now some of the things that we know, like they are an effective tool if you need to get,
right.
When you're using nitrous especially. So
an external wastegate can eliminate the need for you to go to a bigger turbo to maintain your turbo shaft speed. So you can keep the smaller turbo on there, put an external wastegate on it, and use nitrous for the rest of your power. Mm-hmm. Whereas you can do without an external wastegate altogether by simply just increasing the size of your turbine wheel and turbine exhaust housing on your turbo, which bypasses more air coming out of the engine around your turbine wheel and slows your turbo shaft speed down. Mm-hmm. It really comes down to turbo shaft speed, and that's really the piece of data that us diesel guys have completely disregarded in all the street vehicles, and that's something that we never learned until we started monitoring on the S10.
Is there a good option for a street truck guy that wants to monitor shaft speed? Like, does somebody have a standalone unit that? There
are some standalone units. I've never bought one and tested one. Most of the stuff, the street truck guys that are serious about running that level, I would recommend just buying like an AAM logger, doing a dash, and then you can do a analog to a digital converter and actually run a turbo shaft speed. But when that's 400, you'd be drilling, tapping a cover, and making it work. You'd have to count your blades and calibrate it. It would take a little bit to get it correct. Whereas the GT55s, they'll come with a turbo shaft speed port.
And I think a lot of people's appeal for nitrous is because it feels like a cheap power adder. But in reality, when you sit down and look at it and look at what you need to do it properly, it just really isn't. I mean, by the time you buy a controller and you understand how to do all that side of things, and if you actually monitor the things you need to monitor, if you need to add a wastegate, all that stuff adds up. So on a street truck, get properly sized turbos, and maybe change an exhaust housing to where it's a little bit looser so you're for sure not overspeeding stuff, and you can get by without some of that extra stuff. But just make sure you pay attention to all those details before you grenade a turbo and go that route. So
a stock turbo, say 62 millimeter, you can spin those turbos to 150,000 RPM and they won't blow up. But as you go bigger in your compressor wheel, your turbo speed must slow down because your outer diameter of your wheel keeps going faster and faster. Because at 115,000 RPM shaft speed on a small compressor wheel, if you'd measure the outside mile per hour of the wheel, would be much slower than something that comes in a 80 millimeter wheel that has a lot bigger circumference.
So you're putting a lot more load on the shaft than on the bearing set and everything.
So as we go bigger in turbo, we need to go lower on turbo shaft speed. Mm-hmm. And like our 91 millimeter GT55 we had on the S10, we figured out that it blows up at 133,000 RPM. Mm-hmm. But we have our 98 millimeter on the S10 now, and I have the limiter set at 120,000 RPM, and we haven't found the limits of that, and I hope I never do. So I have the Bosch will pretty much catch it once it sees 120,000. It'll start defueling the ECM or the injectors and just keeps the turbo shaft speed from running out of control.
Mm-hmm. So let's go from this a little bit to the electronic side of things, and maybe specific some of the things we've done on a dyno setup versus a proper maximizer full nitrous setup. Let's talk about that a little bit and what the options are.
Right. Well, as far as the Maximizer 5, NX makes it. It is a great nitrous controller. I would recommend it for anybody who's serious about doing nitrous, because for years we just had solenoids on a button. Take a solenoid like this, you wire it up to a relay and you push the button and it's push to pass. It smiles for days. So smiles until you got broken parts. The nitrous controller gives you a lot of protection factors. You can set it to not bring nitrous in until X amount of boost. You can set it to look at RPM, which is a little difficult. I can explain that. But or you can do time-based. If you're racing and leaving off of a staging limiter, as soon as you let off the button, the timer starts on the maximizer, and 1 second in, it brings one kit in, 2 seconds in, it brings another kit in. You can pulse width modulate, ramp it in, ramp it out. There's all kinds of functions that you can do with the maximizer that I would highly recommend it for anybody using it for racing and even on dynos.
As far as nitrous on a dyno, you got to bring it in quick because you're doing a really short window. Is time based the best route there? Is it RPM based? Like what?
I would do it boost based. Let's bring the whiteboard in. Okay, so dyno and nitrous. This is for a big dyno number. This is not for a 500 horsepower truck trying to hit 600. This is for a 1500 horsepower truck trying to hit 2000, or a 1000 horsepower truck trying to hit 1500. And with a dyno, you want to accelerate your truck into max power, max boost as quickly as possible, because what we find is you can't load your dyno too much to where it really creeps through the run, or else if you try to hold the truck back with the rollers, the tires begin to spin on the rollers. So when you get into the run and start your sample, you need to let your rollers accelerate quickly. Well, what happens when you let it accelerate quickly? It doesn't spin, but now you only have such a short window, less than 2 seconds, to get your truck to full power, or else you're out of the sample window before your truck's into boost. So when I talk about nitrous on a dyno, let's look at an RPM curve. So this is RPM. And let's say you start your run at 2000 RPM. And if you do a fuel only run, this is 4500. So now you have a run fuel only. And let's say this made, this curve made 1500 horsepower. You have to apologize, I'm not a teacher, so I'm not great at this, writing on a chalkboard. But, so this is your RPM curve, and you're gonna see your boost curve look very similar to that, because you're gonna start with low boost, and then your boost is gonna do this. So this is boost on fuel only. That way you can understand what I'm writing. Now, when you bring nitrous in, now your power curve, you made peak power at say 3,500 RPM. If you bring nitrous in, let's say you have a Maximizer 5 and you set up to where your first kit comes on at 25 pounds of boost, your second kit comes on at 40 pounds of boost, and your third kit comes on at 60 pounds of boost. So now, as soon as this gets to 25 pounds, your first kit, this boost curve is going to start doing this. And then the second kit comes on and third kit comes on, and your boost curve is going to look like this. And you're going to make more boost, but you're going to make it a lot faster. And your RPM curve is going to come in here like this, and you're going to see a direct change in your RPM curve. And this is this is exaggerated, but by accelerating this nitrous in quickly and ramping in your boost faster, your engine's making more horsepower, and it's accelerating your RPMs much faster, and you make a huge number right in this short 1 second window. And that's the key to making a huge horsepower number, is getting that engine to accelerate its RPMs as quickly as possible in the test window. Because if your nitrous doesn't come on out here, you're already past your peak power window, and you're never going to make the peak power potential. And that's why at UCC, when we're really going for a big score, the earlier in the RPM window that you make your horsepower, the higher your torque number is, and they score horsepower and torque. And that's really what makes UCC competition a bloodbath on the dyno, because you see all these guys is huge turbo setups, just barely into the turbos and just whacking the crap out of it with a big shot of nitrous, and it's go or blow. If it takes it, it accelerates extremely fast. If it doesn't take it, it backfires and fireballs.
You really need to get your nitrous in as early as possible, and you can't turn it all on at once or else you're going to get a big bang. But you all need to turn it all on probably within a second.
Less than a second.
Yeah.
I mean, when you look at, once your boost curve is going and you go 25 pounds, 40 pounds, 60 pounds, that's the safe way of doing it, because it prevents you from bringing in too much nitrous before there's enough boost there. There's a lot of guys who have, in past, Derek Rose, for instance, big kits, one button, hope and pray, spray and pray. And we've done it, I've done it, and it works. But if you bring that button in just a fraction of a second too soon, we can show you a video of what Jersey's truck did. We did that King of the Streets one year.
Well, Derek even had one at ATS where he tried to do a lot of nitrous too soon and ended up with, I don't know, was it bent rods or something of the sort?
I can't remember.
So you're playing on that fine line of getting it all done quickly and hopefully you didn't do it too quick and break things. And a
1 or 2 second difference can be the difference of a hero number or going home like somebody just kicked your puppy.
Yeah. So if you're using a maximizer for dyno, you say RPM base is best.
Well, I would do boost. Boost is best.
Okay.
Yeah, because the problem with RPM and the maximizer is that if you read it off of crank signal, you can't scale the RPMs back far enough to get the accurate crank reading or RPM reading on the maximizer, because it only divide it by 12 and there's 60 teeth, or 58 minus 2. And so we tapped into the cam signal to get RPM, but the problem with the cam is instead of there being a gap for top dead center, there's 3 tones that it reads. So the maximizer will read, it'll be 800 RPM, and then the 3 dots close to each other come for top dead center. So it'll be like 800, 1500, 800, 1500, 800, 1500. So you set your target nitrous to come on at 2800 RPM. Well, it's intermittently reading these 3500 RPM spikes, and all of a sudden it'll bring your nitrous in before you want it. Gotcha. So really the best way to bring RPM reading in on a maximizer would be doing a Hall effect sensor read off of your torque converter bolts or something like that you build a little bracket and have a Hall effect sensor that inputs your 6 torque converter bolt signal into your maximizer. That's why it's not a simple way to just wire it in. I tell guys to just tap into their map sensor signal wire and run it to the maximizer 5. Now, and then you can scale if it's a 10 bar map sensor. It's 0.5 volts is 0 psi, 4.5 volts is 145 psi, or whatever. You can do your factory map sensor, but the factory map sensor will only scale to 37 psi. And then you have something that there's a protection factor in there. It won't bring the kits in until it sees X amount of boost, however you want to program it. And the smaller the turbo, the sooner you can bring that nitrous in. The bigger the turbo, the longer you got to wait, because it's got to get over that hump. But you got to get a channel of air running into the cylinder before you dump a bunch of nitrous in it, or else you'll backfire.
So switching over to using the maximizer for drag racing, typically, how would you advise setting that up? I'm assuming do all boost number there as well, or at what point?
I would do time-based. If you have the ability to do a staging limiter. The staging limiters on any of the trucks that we've been doing, like foot brake, in times past, you didn't have a staging limiter if you didn't have a trans brake. You get on the trans brake, put on the limiter, race letting off the button. But now we're selling a lot of our staging limiter kits. We have them from 03 to 2009 that you can buy the staging limiter to tap into your ECM or off of the map sensor on the 03 to 05 trucks, and we can wire in the maximizer to trigger input number 2 of the maximizer to anytime you're on the button. It disables your nitrous kits, and when you let off the button, it enables the nitrous kits. So the maximizer has to see over 80% throttle, and you have to let go over the button to start a timer. And then in drag racing, it works really well to do time-based, because you're always doing the same acceleration. Yeah. You want to bring your nitrous in sooner, you just shorten your amount of time. And we've found that it works really good. So let's say this is the drag strip here. And this is the start line. This is your 60 foot. So we like to bring, say, like an 060 jet on at wide open throttle.
As soon as you let off the button.
As soon as you let off the button, bring a 60 jet on. And that wakes the tire up right away. It helps with the tire crack. It helps you with your 60 foot time. And you don't have to spool up such a high boost number to get a good 60 foot time, because now instead of having to leave the line at 25 pounds of boost in your race truck, you can leave the line at 20 pounds of boost or 18 pounds of boost, but that 60 jet's going to wake it up and crack the tire. And when you're holding back less boost at the beams, it's easier to drive into the beams, it's easier to stage. You're less likely to burn your converter down if you get burned down at the tree.
Most likely your suspension's going to be happier as well, because you're not as violent coming off the button. You're getting that first move in, like I'm talking first tenth of a second, and then you're bringing the power in.
Right. So 60 jet on the first letting off the button, and then we'll do a 1 second. We'll start the kit number 2, and we'll pulse width modulate. If you ever hear a solenoid pulse width modulate, it's like wah, 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 wah. It just turns it on and off, and we'll start it at like 40% duty cycle, and we'll ramp it to 100% duty cycle by 1.5 seconds.
And all of this depends obviously on the
On your
power of
setup.
your truck and if your suspension can take it and all that stuff. And then, you might start out with an 060 and another kit, and that might be all you have. And down the road, you need to go faster, and so you add kit 2 and 3 and just keep going.
Right. So I'm going to say this based on how we've done a lot of the race trucks. Like Cody Fisher's truck was like this when he wanted to really get after it. And Chris Gelbaugh's truck, I think, is doing it similar to this. And we've got quite a few successful guys out there racing that have 3 kits of nitrous that are leaving the line on a 60 jet. Bringing in, you can do 70 jets. You can move these jets up and down based on the power you want to make. But then at 1.5 seconds, now you start your third kit, and you go 1.5 to 2 seconds that you PWM, and do the same thing, 40% duty cycle to 100% duty cycle. Once the solenoid's at 100% duty cycle, it's 100% on. And you want to build this ramp so it's not just such a violent change of power to where it starts blowing the tires off. And that's why, you're making your power just ramp like this. And the same thing happens here. As these boosts comes in, your boost curve will change just like that. It goes up, and you've got a nice steady boost curve, rather than bringing all 3 kits out here and having a huge spike like that. And that's where it'll spin the tire if you wouldn't pulse width modulate in and bring them in based on time.
Smooth is fast.
Smooth is very fast.
Yeah. So talking about solenoids a little bit, I noticed you were talking about starting all your PWM from 40 to 100. Part of the reason for that is we like to use the NX 375 solenoid a lot. This is the biggest solenoid that we, to our knowledge, by a long shot, that's available. And the 375 is in reference to the orifice size inside of the solenoid. And this is a 2-stage solenoid, is what allows them to have such a big orifice in it and still have a magnet strong enough to open and close it. But the only downside to that is then, with it being the 2-stage solenoid, is pretty much anything below 40% pulse width modulation is off. And anything, I believe, over 70 or 80% is pretty much full on. So they're not quite as tunable as what some of the smaller solenoids are. So if you really need full control and you want to start at 10% and go all the way to 90, some of your smaller solenoids might be a good option.
But they'll have a higher amp draw.
Right, they'll have a higher amp draw, and you're going to be limited as to what you can flow through that. So I might just take this opportunity to go right into talking about flow of all of your plumbing. So I don't know, I guess kind of backing up to where we started with the S10, we thought we were putting a lot of nitrous in this thing, and we'll dig up a picture, but I have like our original nitrous rail, and we had a spool kit, and I'm not sure what the other small one was, but we had 3 main kits, and we had this all on one nitrous rail. So we were feeding it with a -8 line going into a block that had, I believe, 1/4 NPT inputs, maybe 3/8 NPT inputs, but then it had 1/8 NPT outputs feeding all of our solenoids. And I didn't understand that my solenoids were not as big as I thought they were. Turns out that we only had a 120 orifice in each one of these solenoids. So I could put whatever jets I wanted on the end of that, and as long as it was more than a single 120 jet, I wasn't going to flow anything more. Mm-hmm. So pay attention a lot to the solenoids that you're using. Like typically what we'll use this stage 1 solenoid, and this is only good for either a purge or a spool jet. I think it has maybe I want to say like a 50 or a 60 orifice in it. So you can flow some small jets with this one for spooling. And then from there, the next one, and I don't have one here to show you, but it looks a lot similar to this one, is the NX 15300. And that one, it's either a 150 or a 130 orifice in it, but you can run one single big jet with that solenoid. So you can go up to, close to a 136 jet, and that one will flow that. Past that, if you want more, the 375 is the way to go. Like we have run as much as 3 136s off of this, and I'll go into some of those flow numbers a little bit later.
That's what's nice if you run a monster solenoid like this and you have, say, 3 136s, you can pulse width modulate it at 40% and then ramp it in. Because if you'd have 3 136s on a button, I mean, that's an astronomical amount of power that comes in. You're changing your power by 400 horsepower on a button, you're going to lose the tire.
Right. And then the next thing I want to talk about is all of your plumbing sizes. That first setup that I had is I had a single -8 line running into this rail where all my solenoids were feeding off of. And then if you would look at the inside sizes of the fittings that went from the rail to the solenoids, like I didn't have much flow there. So these are small fittings that we use post solenoid, but oftentimes if I'm doing a nitrous setup, your drill bit set is your friend. Before you start putting anything together, put a drill bit inside of this and figure out what your minimum diameter is of your fittings so that you know that you don't have any choke points. You want to try to you never want to go from a small chamber to a big chamber back to a small chamber, because anytime that you do that, your nitrous will potentially change from a liquid to a gas. So you need to always keep stepping down in size as you go up to your nozzle. So pay attention to that. And then also pay attention to make sure that you have the capacity that you need to flow the nitrous that you need to get it to the solenoid. And then you need to pay attention post-solenoid as well. And a lot of this stuff we've learned just by monitoring pressures on the S10 and seeing what data logs do and stuff.
The S10, we have bottle pressure, and then we have pressure after every solenoid. So between the solenoid and the nozzle, we have a pressure sensor. And you can tell quickly as you open every solenoid, the bigger the nozzle is, the lower the pressure is between the solenoid and the nozzle. And the more important it is to get a bigger feed going to the solenoid. Because just changing the feed line can change the pressure after the solenoid, between the solenoid and the nozzle.
Yeah. And so, and some of this stuff you don't have to pay as much attention to if you're doing like a small nitrous setup or whatever, but once you're to the point where you're really wanting to get after it and you want to maximize what you can get.
If you're doing 3 kits like this and you're wanting to get after it and you want to have a 60, 110, and a 136, you need to make sure that your flow is right.
Or if you're in a dyno competition and you're really wanting to get after it, like that's another thing you really have to pay attention to. And then along with that comes the whole thing of paying attention to what nitrous you have in your bottle, what your pressure is, and how full your nitrous bottles are. Man, I remember that one year specifically at the dyno at UCC, we had a nitrous setup on it, and we never even checked the pressure going up to the dyno. And, we had no idea what we really had for power.
Right.
Turns out our bottles weren't full enough. Our pressure wasn't high enough. We didn't gain much from nitrous.
Right.
And so we started out with the S10. We would target 900 PSI, and we kind of picked that number because it was a pretty easy
number to maintain. Anything higher than that, it seemed like we were having to put the bottle warmers on it quite a bit. And
we had also previously had some solenoids that at above 1,000 PSI, you would go to fire it and it wouldn't turn on.
Right. So there is such a thing as too much pressure. If you get up to 1,100.
And I believe there's some different solenoids that have different ratings. Some of them are better for lower pressure.
Yeah, so there is, talking about the 15300 specifically, there's a 15300 and then there's a 15300L. And the L is a low amperage, so that if you have, electrical draw concerns, you can use that. But that one doesn't have the ability to open under high pressure as much as what the regular 15300 does. Recently, we've moved to 1,000 PSI, and some of that was more based off of some of the testing that we did last summer. So we were on the S10, we were at the point where we had more fuel and we wanted to go faster, but we were out of nitrous. And to maintain the air-fuel ratio that we were after. And that's another thing we really need to address at some point is the air-fuel ratio. I'll leave that alone for now. But so if we want to turn up the more fuel, we needed to figure out how to get more nitrous into it. And I already have 3 big kits on the truck, and we're kind of close to our electrical limits of what we can do. So kind of started asking around and talking to some of the nitrous guys like from that do the pro nitrous stuff at PDRA and stuff, and kind of told them what we had, and they said, man, with what you have, that doesn't really make sense with the amount of nitrous you're actually using. Like,
we were telling them our jet sizes, and they said, you should be
using more nitrous. So I started doing some testing, and I just put the whole nitrous system together on the S10. We didn't have the engine in it at the time, and I got a mother bottle out, and I started doing some 5-second tests. So kind of started out with just doing some comparisons. I turned on Kit 2 by itself, and at that time was 399 jets. And in 5 seconds, that used 3.8 pounds. And Kit 3 was 3 136s, and that used just right over 5 pounds. So combined, it was like 8.8 pounds. And then I turned on Kit 2 and 3 at the same time, and it dropped down to 7.5 pounds. So that told me that somewhere pre-solenoid, I'm not supplying as much nitrous as I could to those solenoids. So I started looking, and the way I had my plumbing was Kit 2 and 3 were both mostly drawing from one bottle. Mm-hmm. So I split those up and ran another, I split those up, and then I also added 100 PSI to the pressure. I should have done the same pressure back to back, but I didn't go that far. But the reason for upping that pressure was we started thinking about, like, all of the Pro Boost guys are spraying their stuff into an atmosphere, in essence. They're not spraying it into boost. So when we're spraying into our pipe, you're, in essence, raising your atmospheric pressure.
Because our pressure sensors are between the solenoid and the nozzle, and we're seeing 115 pounds of pressure in that sensor before the solenoid ever turns on, because it's boost pressure back feeding into it. So now the nitrous pressure has to overcome the boost pressure.
Mm-hmm. So we decided, one of the simpler ways to get more nitrous into the pipe was let's just up our start pressure. So now we target 1,000 PSI. And when I changed those lines around and added 100 PSI of pressure, we went from 7.5 pounds in 5 seconds to 8.7. So we picked up, over a pound of nitrous just by making that switch. And then I decided to do an experiment that has more to do, and this is going to show a good bit how your plumbing affects things, how many 90s you use, how many Ys you use, and that kind of stuff. You really want to try to keep your lines as much in a straight line as you can and not use more hard turns than you need to. But I took those 3 136 jets and I did some math, and according to area, that is the equivalent of a single 235 orifice. So I made my own homemade 235 orifice and hooked up a single -6 line instead of the 3 -4 lines going to the 3 different jets. And in that same 5-second test, we went from 8.7 pounds up to 10.8 pounds. So picked up over 2 pounds of nitrous doing that. And that's the setup that we're running currently for our big kit.
And how that corresponded in the real world. I mean, we were hitting our RPM limiter at lights out, but I mean, we put 3 mile an hour on the board over our best mile an hour when we changed that nitrous setup.
Yeah. And I did that just simply with an AN fitting and a drill bit and some tube. But since then, we've started, and I don't have the full kit here, but Tony Durhammer over at HammerTech Race Cars makes some pretty cool stuff. He's got his MegaJet kit that he designed to go along with his nitrous cannon, but you can use it as a standalone jet as well if you would like. So like right here, these are actually an adapter so that if you have his MegaJet in it, you can put this adapter in and you can go all the way down to put a regular nitrous solenoid in this. So you really, with one of these single jets, can go all the way from the tiniest of tiny all the way up to, he has a 3.125, if I can get this thing open, has a 3.125. And I mean, that's straight up, that'll empty your nitrous bottle in a heartbeat, and you'd better have your
That's a
big boy-
heartbreaker.
Yeah, you'd better have your big boy pants on for that one. So that's a really nice setup. And another thing we started using from him is his nitrous rail. And this is also a really nice piece, has a lot of, all of the fittings are straight cut O-ring fittings instead of NPT. So you're not dealing with a lot of thread tape and all that hassle. So really nice piece from his as well. So that I think that kind of gets me on the plumbing side of things. Get into air-fuel ratio a little bit.
Yeah, air-fuel ratio, we should touch on that. I had made a post on Strictly Race Diesel a while ago, kind of touching on that, kind of what we found. I'm going to erase some of this. Okay, air-fuel ratio. This is another thing that we never really educated ourselves on in the diesel world because very, very few people have wideband O2 sensors to actually monitor it. But in some of the testing that we found, we have found that air-fuel ratio plays a big part in how your EGTs respond and how much power per fuel quantity you can make. So I'm going to draw a little diagram, and let's say this is 12:1 air-fuel ratio. This is heavy smoke, 12-valve. Sled puller, yep. And then
Let's roll some coal, bro.
Yep. This is 25:1. And this is 17:1 AFR. So this is very clean. Like, very clean, no smoke at all. And this is a light haze. Again, this is our experience. So if you've got something that you experience differently, share away. But this is what we found. Now, what this hump is exhaust gas temperature at the same power. So we really see this as 2,000 degrees, and this is 1,600 degrees, and this is 1,600 degrees. This is cool because it's over-fueling it, and it's using the extra fuel to cool the cylinder down. This makes great power, and this really makes very little more power than what this does. In fact, this still makes more power, but this is the hottest zone, and that's why most street trucks will max their setup out on fuel, and then they add a little bit of nitrous and it puts it right in the hottest range possible. And they drop valve seats, melt pistons, tear up turbos, all kinds of stuff. Whereas you're better off dialing your fuel back and then going all the way to the lean side of the curve and being 25:1. And so once your smoke's clean with nitrous, you have to add like 2 more kits of nitrous to get to 25:1. 25:1 is
A
lean.
lot of nitrous, and it's hard to get there.
It's hard to get there. Like, people don't realize what 25:1 air-fuel ratio is. Put a wideband O2 sensor in your truck. You'll be amazed how much fuel you got to pull and how much nitrous you got to add to get there. So we had On the dyno with the billet motor, we just started with a baseline run of 300 milligrams of fuel, which was like with our 500% overs was, I don't know, 950 microseconds. I mean, it was just barely turned on. And it made a little over 1,300 horsepower, 1,350. And we were 17-to-1 air-fuel ratio. And we were still hitting about, I don't know, I think we were hitting 1,700 degrees. We decided to not change fuel quantity and only add nitrous. And we are monitoring cylinder pressure as well. And so we added 1 kit of nitrous, 2 kits of nitrous, 3 kits of nitrous. And every time we went from 17-to-1 air-fuel ratio to 18 to 19 to 20 to 21 to 22 to 23, every time we added nitrous, it added power. And we took that 1,350 horsepower and turned it all the way into 1,970 horsepower on the dyno. So a little over 600 horsepower that we added with the same fuel quantity. Like a single 14 mil Exergy pump will flow 370 milligrams of fuel at 4,500 RPM. So that means we can make over 2,000 horsepower with a single CP3 if we do it all the way over here. But that same fuel quantity will be, that same CP3 will be maxed out at like 1,400 fuel only. I mean, depending on your air-fuel ratio. I mean, it's all relative. You have to understand the air-fuel ratio. What I'm getting after is you either want to be heavy in fuel, over-fueling to where it's cooler, or you want to be all the way on the lean side. So we actually recommend backing your fuel back and adding 3 kits of nitrous rather than maxing your fuel out and adding a small kit of nitrous. It's safer to go heavy on the nitrous with less fuel. And now you're also going to make more power with the same fuel quantity, with lesser fuel quantity, and everything's happier. So that's air-fuel ratio just as a base understanding of how it can affect your power. We took a stock truck just the other day. It was actually one of the guys who works in the trains room. Has a stock mega cab, stock lift pump, stock CP3, stock injectors. He dropped a valve seat because he was doing burnouts, pretty sure. He says he doesn't drive it that hard. He's lying. So he had put I think it was a stage 1 head that we had laying around. It was one off of one of the other customers' trucks. Put it on with the ARP 625. So had the head figured out and put it on the dyno, and he had put a Taterbilt 63, 67 on his truck. So everything's stock except for tune and transmission and stock appearing turbo. And it made 545 to the tire, which is about right on par. I mean, pretty good for a stock lift pump truck. And then he's like, how much can we with nitrous? So we sprayed the thing pretty much as hard as we could spray it and made 905 horsepower. So you get that truck all the way to the lean side of the curve, and you go from 549 horsepower to 905 horsepower by adding nitrous. You know, he was excited, he was stoked, but later that night, his turbo didn't survive. And that comes down to what we talked about at the beginning of this video was turbo shaft speed. When you add a huge shot of nitrous, 900 horsepower worth of air has to exit that engine, and it took that turbo shaft speed into infinity. And while it didn't blow up on the dyno, we hurt the bearing on that big nitrous pull, and we had to change the turbo the next day because it died a horrible death later that night. But that is stuff that you can't go back on the turbo manufacturer for because of what we did to that turbo shaft speed. So it doesn't matter whether it's a Garrett. I mean, like I said, we blew that Garrett 91 up at 133,000 RPM shaft speed. Once the turbo wheel goes too fast, it explodes. I don't know.
Yeah, I mean, I would say that covers most everything pretty good. I'm not sure if there's anything we missed on some of that stuff.
There's a ton of info. They're like rolling through my head that I'm like, I don't even know. We'll get in a whole can of worms if we open
the wiring side of things. I might mention a little bit real quick. Like, you have to make sure that obviously all your grounds are really good. You use heavy enough gauge wire. Some of these, I mean, these solenoids are a pretty heavy amp load. And if your wiring is insufficient, it can cause a misfire on a solenoid. Like, your solenoid might not open like you want it to. I think we had that issue at DPC one year when we didn't have proper wiring. Like, you've got to use relays. None of this like trying to, jimmy a little bit of 12 volt power through a switch. Like, You're going to melt things, and your solenoids are not going to work like they need to. So make sure you do your wiring right. Pressures, pay attention to the pressures in your bottles. And
a full nitrous bottle will
Right.
flow more than a half-empty nitrous
Right.
bottle, even at the same pressure.
Yep.
At least according to the test we did.
From the
Should we
110
write out your test samples just on the board so they would
Might not
have
hurt.
everything? Let me write all that stuff down. So I just wanted to write this out so you guys can see the nitrous comparisons that we had tested last summer. And you guys can pause the video and look at this if you want to kind of compare, but this really puts it in perspective. This is your total nitrous that we used in our kits. You end up with going from 8.8 pounds. You move these two kits together, it goes down to 7.5 pounds. Each kit got its own bottle. Well, no, wait, what is that?
Well, so this is when you did kit 2.
This was
by
a
itself.
5-pound test. This was a 5-second test.
They're all 5-second tests. Every single one of these are 5-second tests. This was kit 2 by itself.
Yeah,
Then
that makes
kit number 3 by itself. But that's fine.
Kit number 3.
Yep. And then when you combine those together, it's 8.8 pounds. But then when I turned both kit 2 and 3 on at the same time, we lost a pound of nitrous. So
Because
that
of
was
the bottle
telling me-
pressure drop.
That was telling me that I had some kind of a flow restriction pre-solenoid. And when I went to look, I had kit 2 and 3 were mostly feeding from one bottle because of the way I had my Ys. So I changed that around to where I had kit 2 off the one bottle and kit 3 off the other one. I did have a balancing line between the two bottles, but I don't have the flow capacity in that balancing line. So I had to get my solenoids on separate bottles. So then by changing that plumbing around and adding 100 PSI, we picked that pound back up. And then really the biggest thing that I learned in that whole thing, and the biggest change that we made, was going from the 3 136s to the single 235.
Yeah.
And that shows a little bit. So either we were, like when I had the 3 136s, I was going through the solenoid, I was going to a 3-way splitter, so there's some turbulence there. Then I was going through 3 -4 lines, all going through 90-degree fittings at the end. And then I changed that over to a single -6 line with straight fittings into a single big orifice. And we picked up, 2 pounds, right at 2 pounds of nitrous in that 5 seconds. And so have a lot less restriction. Most likely in this setup, some of that nitrous was turning into a gas in the line. So you can't get near as much nitrous through the nozzle in a gas form as you can in a liquid form.
Right.
So there's a lot of things you need to pay attention to when you're trying to maximize your nitrous setup. And I still don't know that I have it fully maximized, but we definitely picked up a good bit of nitrous.
The main point of this is to show how big of a difference just a few small changes can make in how much nitrous you want. In the S10, that took us from 181 miles an hour to 184 miles an hour with the same fuel quantity, just by doing this change right here.
Yep. And then as far as making up nitrous lines, like you can see here, the difference. So all of your shark fins, where you put your nozzles in, that's where all your jets go, but that's all -3 stuff. So if you use an actual -3 line with a -3 fitting, your orifice size is super tiny there. Like I don't think that would flow much more than an 80 or a 90 jet. I don't remember. I'd have to check that size, but pretty much all of our nitrous lines are a -4 line with a -3 nut on it. So same fitting on this end, but if you compare the fitting size, I don't know if you can zoom in on that, but it's significantly bigger. So you have to pay attention to all of that stuff if you want to flow a lot of nitrous. Really, that's what we've learned with our nitrous setup stuff. One more thing I might touch on real quick here is like filling nitrous bottles. There's a couple different ways of doing that. When we started out, we would use a nitrous pump, and we found that to be fairly frustrating. I know some guys have had pretty good luck with it, and I think maybe depending on how many bottles you fill and like how often you use it might depend a little bit on how you do it. But the way we like to fill bottles is we have a really big heater to put on our mother bottle. a couple different manufacturers that sell big mother bottle heaters, and you get the mother bottle hot, and so you get the pressure up in the mother bottle, and then you put your nitrous bottle in an ice chest and get it cold, so that drops the pressure in it. And then you simply need to put a transfer line in between with a valve, and you also want to make sure that you have a good filter on it so that you don't get contaminants in it. If you get contaminants in, you're going to start getting clogged solenoids and all that fun stuff. But then you just transfer through pressure balancing. So we'll fix an ice chest at the start of a race weekend and get the mother bottle on the heater, and we can quickly fill bottles throughout the race day that way. And that's kind of our preferred method. Whereas if you're just doing a bottle every now and then, and it's a little bit of a hassle getting ice around and waiting for your bottle to warm up and stuff, a pump might be a better way to go. So that's kind of some options as far as filling bottles.
We've had 3 different pumps, and they seem to only last about a year, and then we're rebuilding them. The seals are starting to leak, and we finally just got tired of always sending it out. And
when they go bad, you're kind of left high and dry if you're in the middle of a race weekend.
Right. The pressure balance way, it's kind of a foolproof. If you've got heat and you got ice, you can fill a bottle.
Right.
Okay.
So yeah, hope you all enjoyed this. Hopefully we didn't tell you a whole lot of stuff that's unnecessary, but I think should be a lot of good information there for anybody that's considering nitrous. And thanks a lot for watching, and we will see you guys on next week's episode of Firepunk Fridays.